All right, we'll start with the IM1 patterns midterm from the fall 2020. So the first thing that we were looking at was a petri dish that is filled with 150 bacterial cultures. Okay. And the number of bacteria we are told in the dish triples every hour. So when something triples, right off the bat, I'm thinking that this can't be arithmetic. We're not adding or subtracting some common difference here. All right, so when we're tripling, that's going to be a multiplier. So we're thinking common ratio here, which that screams geometric series. Okay, so the first thing that you had to do was represent the number of bacterial cultures in the dish for the first 5 hours as a numeric sequence. Okay, so this is just simply showing the first 5 terms in the sequence. So we have our first term. Okay, the value of our first term is 150. We have our second term. The value of our second term is 450. Our third term is 1,350, and so on. Now, how are we getting those things? We're multiplying by the common ratio of 3. Okay, our common ratio is 3. Now, part B says develop an explicit formula and use it to predict the number of bacterial cultures in the dish after 10 hours. Be sure to identify the components of the sequence. Now, a lot of us are overlooking the directions here. Okay, we have to make sure that we're reading each and every part very carefully. So identifying the components of the sequence, that's one of the key parts that we need to do first. So A sub 1, that's just our initial term. Okay, in this case, it's 150. That is the initial bacterial culture amounts before that number starts tripling. R is going to be our ratio, also known as our multiplier. And in this case, remember, we know that it triples. So that's going to be 3. Now, our explicit formula is A sub n is equal to A sub 1 times the ratio n minus 1 times. Okay, that's just the explicit geometric formula. Now, when we substitute our components, we have 150 for our initial value. We have 3 for our ratio. And then we're ready to start to evaluate using our formula. Okay, so now we need to determine, using our formula, how many bacterial cultures are in the dish after 10 hours. So we're just simply going to substitute 10 in. Okay, A sub 10, substituting 10 in for n. We also have the 10 here, substituted in for n. Okay, just step by step simplifying here. That is going to be 150 times 3 to the 9th power. 3 to the 9th power, you may have used a power table. You may have use the Google calculator or a calculator at home, but this is not 3 times 9. This is 3 times 3 times 3 times 3 times 3, 9 times. Okay, so that turns out to be a pretty large number. 3 to the 9th is 19,683. You multiply that by the initial term 150, and after 10 hours, what started as 150 bacterial cultures is now 2,952,450 bacterial cultures. Okay. Now, part C, things get a little bit crazier, and some of you guys just continued to multiply and you did A sub 15 and you substituted it in using the formula. You would not have received full credit there because we wanted you to show it graphically using technology. So in Desmos, what your teacher is going to do right now, and because I'm hard copying this, I'm not doing it on the computer. What your teacher is going to show you now, they're going to press pause in just a second, is they are going to put the formula in and they're going to show you how you would determine what the bacterial culture amount is after 15 hours. Again, doing that with Desmos and then taking a screenshot. Okay. That amount comes out to 717,445,350. It's large, lots of bacteria. Okay. Now, on to number 2. We have the sequence 5, -2, -9, -16, and -23. So using that sequence, your guys' task was to determine an explicit formula, okay, and identify the components. So here, clearly, hopefully you picked out that this common difference is going to be -7. Okay, we have our sequence here, 5, -2, -9, -16, and -23. Now, as we move from the first term to the second term to the third term to the fourth term to the fifth term, we are subtracting 7 each time. Okay, that's our common difference, negative 7. So identifying the components here, key parts, the common difference, again, is negative 7, and that's going to be represented by D in our explicit formula. The initial term is 5, and that will be represented by A sub 1. Again, that's just our initial term. And when we substitute it into the explicit formula, A sub n is equal to A sub 1 plus the difference n minus 1 times. When we substitute that in, the formula that results is A sub n is equal to 5 minus 7 n minus 1 times. Okay? So that's all of this would have been full credit for part A, 2A. Okay? Once again, you've identified the parts of the arithmetic sequence, you have the explicit arithmetic, and you have substituted incorrectly. Okay. Now B once again says represent this data tabularly and graphically. You had to include a screenshot from your work using Desmos. So once again, your teacher will pause right now and we'll take this thing on over to Desmos, plug it into a table, and show you what that thing looks like, and show you what full credit would have looked like if you did it on Desmos correctly. Okay. Now, C and D, at this point, you're just evaluating your explicit formula. Okay, so you had to determine what the 250th term in the sequence would be and the negative 152nd term in the sequence would be. And again, showing all your work. Okay, so the first one here, again, it's just evaluation. Okay, so you're starting with A sub 250. That simply means that you're just going to substitute 250 in for n. 250 minus 1 is 249. So this is not 5 minus 7. The order of operations say that multiplication comes first. So 7 times 249 is negative 1,743. And then you're going to have to do 5 minus that 1,743. And that comes out to negative 1,738. Okay. Now the last one here, you had to do the negative 152nd term. Okay, now a lot of you, well, my class at least, when I was grading them, when they substituted this in, the negative 152 minus 1, some of you guys were putting negative 151. You were adding 1 for some reason. Negative 152 minus 1 is negative 153. Okay, and this negative 7 times that negative 153 becomes a positive 1,071. And now even more, some of my students were just leaving it as 1071, but you forgot to add on that 5 at the end. So ultimately the answer here, the negative 152nd term is 1076.